guys. One of the common problems under the two pointers category is the longest palindromic substring, which is what we're gonna discuss today. So, what I'm trying to find here is a substring of this given string, and it has to be a palindrome. What is a palindrome? A palindrome is something that starts that reads the same way from left to right and from right to left. So, for example, B A A is a substring of that given string. But if I start reading from left, I'll start with a B, and if I start from the right, it starts with an A, so this is not a palindrome. However, if I add the B over here, Bab, well, it would start reading the same. And then if I move to the A's, they're the same. And a palindrome can be odd or even, so suppose I only have one A, that would still count as a palindrome. So this is what a palindrome essentially is. And I want to find a way to solve this problem. So let's first think of the brute force solution. The brute force solution is the easiest solution one can find. Whereby it's like the exhaustive solution. And to do so, this shouldn't be hard. We could think simply of every single substring that I can have from this string. So if I start, for example, if I start at I, suppose I is where my substring starts, and let me take this to be the J, the second loop. So I can have this as the first substring, starting from I, ending at I. Then I can have BA. I can have BAA as the third substring. I also can have BABB. That's the fourth. Then we have BAABA, and finally the entire thing. So those are all the possible substrings that start with B, but that's not it, right? So essentially I just looped once, but that's not it. Maybe my palindrome, maybe the longest palindrome in my string doesn't start at B. Maybe it starts at A, right? Or maybe it starts at this A. It could be like ABBA here. ABBA is a palindrome. So I have to do different starts. So here's the green color. I'm gonna start from here this time. So this is my first substring. This is my second AA, AAB, AABA, and then AABAD. And I can keep doing that, so I have to start from here this time. And notice when I start from a place, I don't check the indices that have passed already, right? I just want to read this part. So I keep doing that till I reach the last letter, right? So I have two loops. And these two loops will generate my substrings, will generate all the substrings of this string. Okay. So suppose we're at I equals 0. At j equals 0, we'll get B. At j equals 1, j is where my substring ends and I is where it begins. So 0, 1, ba. 0, 2 for j equals 2 will give me ba. 0, 3 will give me BAAB. 4 will give me BAABA. And 5 will give me the entire string. And the loops will keep doing the same thing as mentioned. So is this all? No, it's not all, because I have to check whether the generated substring is actually is actually a palindrome or not, right? So I'm gonna have a helper method called isPalindrome to check for me whether a certain substring is a palindrome or not. Okay, so as I just said, we need to check whether the generated substrings are palindromes or not, and we need this helper method. So let's start by typing the pseudocode for this helper method. Okay, so I'm gonna start a left pointer over here, call it L, and a right pointer. Same for the even case. So while L is less than right, while the left is less than the right, um, first I have to initialize the L to be 0 and the R to be s.length minus 1. So while L less than R, if s dot the character at L is not equal to s dot the character to the right, then it's over. No, then it's over, you just return false. But if the entire while loop is completed, and we didn't return false, it means it is actually a palindrome, and I'll return true here. Let's see why this works, because, okay, so here L is 0, R is this. Okay. Oh, and if not, by the way, if not, we have to remember to increment the counters. We forgot to increment the counters. So if not, so if we did not return the false, and we're still inside the while loop, we have to do L++ and R minus minus. Okay. So my L will become here and my R will become here, and that as a next step in the odd case. So they'll both be at index 1. So is L less than R? No. So I'll directly return true, and this would give me the right answer because this is a palindrome. In the even case, the L will become 0, the R will become 1. So L is less than R. I'm gonna enter here, realize they're the same. Sorry, realize, yeah, they're the same, they're both A's. So I wouldn't return false. I'm gonna increment again. Then this means the L will become 1 this time, and the R will become, sorry, the L will become 2, and the R will become 1. Yeah, the R will become 1. So in this case, it would stop because left is now more than right, and it would return true. Okay, so let's implement the helper function. So yep, we're gonna call it isPalindrome, and it's gonna take a string s. Okay, so int left is 0, int right is s.length minus 1, while left is less than right. Yeah, if s.car at left is not equal to s.car at right, return false. Yep. Where do we have an error here? Oh, it's not supposed to be false. Sorry, it's supposed to be Boolean. Okay. Otherwise, if all is good, just increment the left pointer, decrement the right pointer. And what else do we need to do? Yep, if we exit the loop, then just return true. So this is our first piece of code. And now let's write let's write the method that does the entire thing, which takes in a string s and returns the longest palindrome in that string s. So first of all, we're gonna have a string. So first of all, we're gonna have a string builder, and we're gonna call it current longest. And what this string builder is gonna hold, it's gonna hold the longest substring we have up till a certain point in time. And when we get something longer than that, we're gonna change current longest and put the new result inside. Then let's call n is the length of the string. And now let's have those two loops that we talked about that are going to generate every single substring. So int I is 0, I less than n, right? And we're going to increment I. Sorry, only two pluses. Okay, and then we're going to have the same inner loop. We're going to call it j, and j is equal to I. J less than n, j plus plus. Notice that you have to start the second one from I. And what this implies basically is that when I start I1, I don't look at the 0. So I don't start my j counter from 0. I start my j counter from the same index I. Okay, so this should be easy. And now I have to generate my substring. So string substring, let's call it substring, is equal to s.substring, and the index is I till j plus 1. Okay, so it means that the index ends at j, but the substring method works like that, so it doesn't take it doesn't take into account the last one, so we increment by 1, okay? And next we have to check whether this generated substring is actually a palindrome. So if is palindrome, yep, if is palindrome substring, yep, what do you want to do? If it is indeed a palindrome, we need to check its length, right? So if substring.length is greater than current longest dot length, then you need to empty the current length string, and then you need to replace it with the current substring, which is called substring. And okay, after we finish both loops, we want to return the current longest, right? So we want to return the current longest, but we need to make sure that we're returning a string. And current longest is a string builder, which is the mutable form of a string. So in order to be safe, we just apply this method called toString, and we're done. Okay, so now let's test. Let's test it. So system.print app, so print system.out.println longest palindrome of. So let's give a few examples here. Babbed, right? This is the example they gave. Okay, so here are some test cases, but just one teeny tiny thing is that let's have some precautions here. So if S, so I forgot to add some edge cases. If S is null, or S.length is 0, just return an empty string. Return empty string. Okay. So now I think the code should work perfectly well. This is called longest pal brute force. Okay, so let's compile it. Javac longest pal brute force dot Java. Now we're running the bytecode. So longest again pal brute force dot Java. Okay, so it's running correctly, I guess. The first one, indeed, Bab is a palindrome, and it's the longest one, right? Yep, it is. Oh, the example had an ABBA here. So, let's run it again. But regardless, SS is a palindrome, so it returned the same string, and it's an even. This was an odd case. Now it's even after I added the A. And let's test this EE. Okay, EEKSS. Okay, till now this is a palindrome. If I add a K here, oh, we have two symmetric Ks. Okay, and two S's, and then EE. So the entire thing is a palindrome, and it did return the entire thing. Okay, so yep, I think that our code is working correctly. But this is the brute force algorithm, and it runs in. Not sure if I've hinted that before. No, I haven't. Okay, so we're having two outer loops to generate every single substring, and when we're having those two loops, this is order and squared, right? Because this is for these two loops. But then we also have this helper function that is checking whether our string is a palindrome, and at most it's gonna do order and work for each substring that's generated, and I have to multiply those two, which is gonna give me order n cubed, which is a very bad complexity. It's a very big complexity, and if we could reduce it, then that would definitely be better if we could reduce it to quadratic, and the optimal solution is quadratic. So let's think of how we might do that. So the best way to do that, again, is to take this example with us and try to think out loud in different ways. Okay, so the approach that's order n squared is very interesting. It says that start at each letter, so we're going to start at index 0, and then assume that this is the center of a palindrome. Yep. Okay, so you would say, all right, but I have nothing to its left, and I only have something to its right, so this is like the odd case, right? So this cannot be a palindrome if we're in center B. So that's the odd case, right? And the odd case for the first example just doesn't work. Okay, so it's not a palindrome because, of course, I'll be checking for the bounds of the string, definitely. But then I just checked the odd. Now let's check the even. For the even, I just check these two. I check index I and I plus 1, and then I expand from there. If I had, for example, BB, I could consider this as a palindrome. So this is it for all the substrings could be generated starting from B. So now, yes, so let's write them so that the picture is clearer for you. For the odd, I only have B because I have nothing to the left of B. And for the even, BA is not a palindrome because I don't have a BB. So since I and I plus 1 are not equal, I'm just gonna skip. All right. So let's have this pseudocode session, if you will. So for the odd case, I'm checking I minus 1 with I plus 1, right? And for the even case, I'm checking I and I plus 1. But you don't even need to think of the odd case as that because we can start both. Yeah, we could start both actually at I, and then at each iteration. So essentially, we're having two pointers, a left pointer I and a right pointer I, and then the left pointer is being decremented and the right pointer is being incremented. So we'll have I plus 1 with I minus 1, and then we'll be checking I plus 2 with I minus 2, etc., etc. Okay, for the even case, we're initializing L to I and R to I plus 1. And we're expanding from there. Okay, so that's just the case where B starts. Let's where B is the center. Let's see some other cases. So now the counter was at I equals 0. Now we did all the substrings. So now let's no, see, we didn't even need to we didn't generate all the substrings. We just checked if B was the center. What palindromes do I have? At most, I'll generate 2, right? I'll keep doing this loop to generate 2. But here I have this one palindrome. So now when I iterate, this is gonna become the center. So for odd palindromes, I'm gonna check this with this and realize that they're not equal. When I decrement L to B to the 0 and when I increment the R to the 2. So it would stop there and realize that this is not a palindrome. My loop would stop working. So this checks for the odd case, but now for the even case, right, I will initialize my left counter and right counter here at I plus 1. And since they're equal, I will expand outwards. So this will become my right. And then this will become my left. And now I can no longer expand outward because I will go out of bounds, right? So I will get at center A bigger palindrome, which is BA AB. So this is a very interesting way to make my O(n) cubed and O(n) squared. And then I'll keep repeating the same thing. I'll take, let's do it one more time. Now the center has reached this part. Okay, so I'm still within this loop, and this loop is doing uh, order n work to check this, because here I have order n for the even case, and for the odd, and for the even O(n), so that's like order 2n, which is still O(n), multiplied by O(n), which is the time to run over the entire loop, and you get an O(n) squared. As I said, just one more time, I'm gonna check. Odd case will give me A, B here, so it's not a palindrome. I'll directly terminate my loop. And my A, for the even, the A is not the same as B, so I'll terminate my loop. And then the pointer at I will increment, so B will be the center, and I'll keep repeating the same thing. ABBA is another possible choice, right? When I expand at the center, and so yeah, it is, but it's not as big as BAAB, so it's not gonna take the place of the current longest. Okay, so since we just understood it in theory, let's go and implement it in code. So, as in the first case, we have to build a string builder, and we're gonna call it current longest. Okay, and then int n, which is gonna be s dot length. All right, and now I wanna do the expand around the center method. So, okay, first of all, we have to loop for I from 0 to n. Meaning that all the indices will get the chance to be the center. Okay, now what will happen is check for the odd case, whereby we initialize the left pointer to 0 and also the right pointer to 0. So, sorry, to I. Okay, and while the left is still big. Okay, so first we're gonna check for the bounds. So while left is greater or equal to 0, and right is less than n, right? And you want to make sure it's a palindrome, so s.car at left is equal to s.car at right. Okay, while all of this is true, why am I having an error here? Oh, okay, so I have to initialize it this way then. Okay, in this case, I'll have them on separate lines, it's better. Okay. While this is true, I will keep decrementing my left counter, incrementing my right counter. And when I get out of the loop, I know that I no longer have a palindrome. So the last thing I have was the palindrome, right? So now is the time to generate my substring. So substring is is equal to s dot substring from the left side, but now the left was decremented. Okay, so suppose the last thing I had was bap, where okay, no, let's take this here. Because I want an odd case. Abba, okay. So the left was pointing here at 2, index 2, and this is index 4. Okay, so this was still a palindrome. Now, right is at index 5, left is at index 1. The while loop will realize that, okay, the bounds are correct, but the A is not equal to the D, so I don't enter this loop. So now I need to get the indices of the palindrome, so I need to correct the indices. I need to increment the left by 1 and decrement the right by 1. So I need to correct my indices. So I'm gonna increment my left by 1. And for the right, okay, for the right now is incremented by 1. But because the substring that always doesn't count the last this, it leaves it. I'm gonna keep it incremented by 1. So it would take the right substring, because the substring method just doesn't look at the last index. For example, if this is my last index, it would just give me ab and not abba as a substring. So that's why I want the right to stay here so that I could get abba. Okay, I hope this is clear. And okay, hooray. So this checks for the odd case. Now I need to check for the even case. So for the even case, I need to initialize the left to be I and initialize the right to be I plus 1. And I'll expand from there. Now this is giving me an error because I already defined left and right. Okay. Don't worry about, about what the values of left and right were when we did the odd check, because I'm returning them to the base. Okay, I'm redefining, so it's like I'm doing a restart when I'm writing them again in terms of I. Okay, so now we have this. What are we supposed to do? We're supposed to keep expanding, right? So I could copy basically the same conditions. First of all, this only checks for the bounds, so I'm fine here. And then I'm gonna check whether these are equal. If they're equal, okay, I'm incrementing the right, decrementing the left. So suppose my I is 1, so the left would be 1, the right would be 2, and then I'll increment this, decrement that, so my left will be here, my right will be here. So this absolutely makes perfect sense. And then I'll get this substring in the same way. Okay, and I don't need to re-explain the logic behind these adjusted indices here, okay? I already did. Okay, so now I am generating the substring, which is a palindrome, I'm sure, but I forgot to do something. Actually, I intentionally left it till the end. I have to check whether the length of the generated substring is bigger than the current longest. So let me do that check. If substring dot length is bigger than current longest dot length. Okay, so if it is indeed bigger, then I want to set current longest dot set length to 0. So I want to erase everything that was already stored there and append the substring. And I'll do the same thing for the even check. And now let's run it. Do I have anything wrong here? Longest okay, what's wrong? Oh, okay, okay, still didn't return. Okay, so after I do all of these, after my for loop finishes, I have to return. And so here's where my for loop finishes. Here I have to return. I have to return the current longest, right? But the current longest again is a string builder, so I need to convert it back to string, and now I'll return it. Okay, so let's run it. Compile into bytecode. My file is called longest pal x.java. Okay, no compilation errors, perfect. Java longest pal x.java. And it gave me the same results as my last program, except this program has a higher performance. So this is it for this video. I hope you understood both solutions, and I'll see you in the next one.